Hello my dear friends, welcome to class 9 science. I am Soham Jagad. Welcome you all. In last lecture we are in chapter number 10, that is gravitation, and in the last lecture we have discussed about topic that is thrust and pressure. We understood thrust and pressure by some example. Now we know what is thrust and what is pressure. Thrust is nothing but that is force acting perpendicular to surface. Thrust is force that is act perpendicular to surface. I have told you that force can be in any direction. It can be vertical, it can be horizontal, or it can be inclined at the plane to the plane at any angle. But when we talk about thrust, that is the force perpendicular to surface. After that, we have seen what is pressure. Pressure is thrust per unit area. Pressure is thrust per unit area, and we can say that perpendicular force per unit area. Perpendicular force per unit area, that is defined as pressure. Now we have SI unit of thrust and pressure. As we know that thrust is nothing but force perpendicular to surface, so the SI unit of thrust will be SI unit of force, that is Newton. And here you can see the pressure is thrust divided area. So the SI unit of thrust is Newton divide SI unit of area, that is length multiply length, and SI unit of length is nothing but meter. So meter into meter, that is meter square. So we have SI unit of pressure as Newton per meter square, that is SI unit. But in honor of scientist Blaise Pascal, we give SI unit of pressure, that is Pascal. So SI unit of pressure is Pascal, and remember 1 Pascal is equal to 1 Newton per meter square. 1 Pascal, we can denote Pascal as PA, capital P, small a, that is written here PA. So 1 Pascal is equal to 1 Newton per meter square. After that, we seen pressure in fluid. Pressure in fluid. In fluid, we include both gases and fluids, that is liquid. All gases and liquids are fluid. What is fluid? Substance that can be flow, called as fluid or known as fluid. So we have all liquids and gases are fluid. As we know that solid exert pressure on the surface due to its weight. Solid exert pressure due to its weight. For example, if I put something on my hand, something solid thing on my hand, what will happen? It will create pressure. It will exert force. Why? Because it has some mass, it has some weight. So that is the property of mass and weight. Similar way, fluids have weight and they also exert pressure on the base and wall of container. In the last lecture we seen it by example how a container filled with the fluid exert pressure on base and walls. In our festival, we fill water in balloon, colored water in balloon. If the balloon, if the quantity of water will be very much large than capacity of balloon, what will happen? It will blast. Why balloon blast? Because there is a pressure due to the fluid contained in balloon, and this pressure will be on its wall. Similar way, sometimes we seen blast in our bicycle tire. What will happen in summertime if we have a comparatively larger amount of pressure already in our bicycle tire, and when it takes heat from outside, it get expand. What will happen? Gases expand, and when gases expand, this exert more pressure on walls. This exert more pressure on walls, and due to this pressure, the blast will happen. So I hope you can understand how fluids exert pressure on its wall and its base. Now, pressure exerted in any confined mass of fluid is transmitted undiminished in all direction. This is important sentence, that is pressure exerted by confined mass of fluid is equal in all direction. That will be equal in all direction. Suppose this is the walls of container. This is the wall of container. The whole pressure, the whole force will be same in all direction. That will not happen that in half of the part it exert higher force, or on half of the part it will exert less force. This pressure and force will be same in all part of container wall. Now we have important topic, that is buoyancy. We have some question. Swim in a pool, felt lighter. Have you ever drawn water from the well and felt that the bucket of water is heavier when it takes out from water? Have you ever wondered why ship made up of iron and steel does not sink in the sea water, but whether the same amount of iron and steel in the form of sheet would be sink? We seen in last lecture that ship are in particular shape and the sheet are in another type of shape, because this shape quantity and this shape quality, shape is, these ships are float on the surface of water while the sheets are sink in the water. After that we seen activity number 10.4. In that activity we seen that we take one empty bottle, plastic bottle, close its mouth with cap, tighter cap or say stopper, and we try to push this bottle in bucket full of water. What will happen? We realize that there is force acting upward, that is force acting on our hand while we try to push that bottle. Now in previous lectures we have seen that gravity pulls object towards earth. Now what will happen? This bottle tries to come out. What will happen here? Is there no gravitational force? No. There is gravitational force there also. But due to force exerted by water or say any fluid, when anything we dip into, any object we try to dip into fluid, it exerts force that is in opposite direction. It exerts some force on it. That's why we feel force in our hand while we try to push empty bottle in container filled with water or any fluid. So we have the force due to the gravitational attraction of Earth acts on the bottle in downward direction. As we mentioned, there is gravitational force also. So the bottle pulled downwards, but the water exert an upward force on bottle. But the water exert upward force on bottle. Thus the bottle is pushed upward. We have learned that weight of an object is the force due to gravitational attraction of Earth. In previous lecture we discussed about that gravitational force is due to weight of object. When the bottle is immersed, the upward force exerted by water on the bottle is greater than its weight. What will happen when bottle will emerge? In that situation, the gravitational force is lesser compared to the force applied by fluid. Fluid applied force in upper direction while gravitational force in lower direction. What will happen? We can take simple example. If I have one object, say I have this paper. I pull this paper from both the side. I pull this paper from this side and also pull this paper from this side. What will happen? This paper moves in direction in which there is a larger force. Of course, if I apply larger force in right side, it will move to right side. If I exert larger force in left side, it will move to left side. Which means when object is exerted by one or more force, it will move in the direction where there is a larger force. So in this case, force exerted by fluid is larger on bottle, that is in upward direction, compared to gravitational force exerted on bottle by earth. So I hope now you understood what is the phenomena happening here. To keep the bottle completely immersed, the upward force on the bottle due to water must be balanced, as we mentioned here. Now, if I want to fix this paper here only, what should I do? I have to balance this both force. I have to balance this both force. If I pull with somewhat example, say we have 10 Newton. If I apply 10 Newton here and if I apply 10 Newton from here also, then what will happen? This 10 Newton and this 10 Newton will be balanced and there is a no net transformation of this paper. It will not move in this direction or this direction. I hope you can understood what is balance of force. I apply 10 Newton force on this direction and 10 Newton in this direction. So these forces are equal and opposite in direction. That's why this paper will be imbalanced. So that will happen if we want to completely immerse the bottle. We should apply same amount of force that is acted on bottle by water. This can be achieved by externally applied force acting downward. What we have to do? We have to apply more force. We have to apply more muscular force, that is external force. External applied force acting downward, that is our hand, our muscular force. This force must at least be equal to difference between upward force and weight of bottle. What will happen? This should be at least equal to or difference between upward force and weight of bottle. The upward force exerted by water on the bottle is known as, remember, upthrust or buoyant force. The upward force exerted by water on bottle is known as upthrust or buoyant force. In fact, all objects experience a force of buoyancy when they are immersed in fluid. As we mention here, when we put any object in water or say fluid, it exert means fluid exert force on object. So all object experience force of buoyancy when they are immersed in fluid. The magnitude of this buoyant force depend on the density of fluid. The magnitude of buoyant force depends on density of fluid. What is density? We know mass density, that is mass divide volume, that is mass per unit volume, that is our mass density. And I hope from this definition and formula now you can derive SI unit of density. Density is mass by volume. So SI unit of mass, that is kg, and SI unit of volume, volume is meter cube. So we have SI unit of density as kg per meter cube, kg per meter cube, that is nothing but SI unit of mass density or say density. I said particularly mass density because in your higher standard you will study about another kind of density also, but in this standard we are fine with word density, that is nothing but mass density. Now we try to understood the reason behind floating and sinking of object in water or any fluid. So we have our topic 10.5.3, why object floats or sink when placed on the surface of water. Let us do the following activity to arrive an answer for the above question. We want to find a reason behind floating and sinking of object in water. We have activity number 10.5 here. Take a beaker filled with water. Take an iron nail and place it on the surface of water. Observe what happened. Now we know that if we put iron nail on top of the water, the nail will sinks. The nail sinks. The force due to the gravitational attraction of Earth on the iron nail pulls it downward. As we discussed earlier, nail moves downward. It means that downward force has more magnitude compared to upward force. Then and only then nail can move downward. If there is any force that will be more than gravitational force applied by earth on nail, it will be moving other direction. But the nail sinks due to gravitational force of earth that is higher than other magnitude of force. So what should we think? Is there no any upthrust or buoyant force? No. There is an upthrust of water on nail also, which pulls it upward. But the downward force acting on the nail is greater than that of upthrust of water on the nail. So it sinks. Here we have a reason while why iron nail sink in water. So we have to write this reason. We have to mark this. This is the reason why nail sinks in water. Because there is a upthrust of water on the nail which pushes it upward, but downward force acting on the nail is greater than upthrust. So we have sinking of nail in water or any fluid. So we have activity. Now we put different thing in water. Take a beaker, fill with the water, and now we take piece of cork, that is wood, and iron nail of equal mass. We take two things. One is iron nail and one is cork or say wood. This both has same mass. Place them on the surface of water, and now we place both the object on surface of water. What will happen? We can see here this cork or say wood will float in water and this nail will sink in water. The cork floats while the nail sinks. This happened because of the difference in their density. We have another reason here why cork floats while nail sink, because it happens because of difference in their densities. Because density of wood or say cork or density of iron will different. The density of a substance is defined as mass per unit volume. As we discussed earlier, the density of substance is defined as mass per unit volume. The density of cork is less than density of water. This means that the upthrust force of water on the cork is greater than the weight of cork. Here we have another reason why cork floats on water, because the density of cork is less than the density of water. This means that upthrust force of water on cork will be more than the weight of cork. So this cork feels more force in upward direction as downward direction than downward direction. There is gravitational force on this cork also, that is in downward direction, but here we have larger upthrust. So larger force will be move on upward direction. So the cork is float on water. Here in place of cork, if we given any object, say ice, we can put this reason here. The reason that anything or any object floats on fluid, because there is a density difference, that is the object has less density compared to that particular fluid. The density of iron nail is more than density of water, and same reason but opposite kind of reason, that density of iron nail will be more than density of water. This means that the upthrust force of water on iron nail will be less than the weight of nail, so it sinks. Here this time also we have two force, upthrust force of water and gravitational force of earth, but due to its density of iron that is higher than water, water can exert less force on iron nail, and this force will less by its weight. So the weight of iron nail will be larger and it will move downward and it will sink. Therefore, object of density less than of liquid floats on the liquid. The object of density greater than the liquid sinks in the liquid. Now we have conclusion. we should mark it and write as a note in our notebook. If object has less density than a liquid, it will float on liquid, and object has higher density than a liquid, it will sink in liquid. Now we have Archimedes principle. Archimedes principle, we understood this principle by one activity. Let's take a piece of stone and tie it to one end of rubber string or spring balance. Suspend the stone by holding the balance or string as shown in figure. Here in figure we have one stone here. We tied it with string and suspend it with string, or in place of string we can use spring balance also. Note the elongation of string or the reading on the spring balance due to the weight of stone. This string is rubber like material, so it will elongate, it will stretch. Now we have to notice the stretching of the string, or if we took spring balance, we have to notice reading of spring balance. Now what we have to do? Now slowly dip the stone in the water in container as shown in figure. Now we take this string and stone and dip in water container. Now we observe here elongation of string or reading on the balance. What will be our observation? Elongation of string. This elongation of string will be decreased, and reading of spring balance also decreases. So we have point here. You will find that elongation of string or reading of balance decreases as stone is gradually lowered in water. However, no further change is observed once the stone gets fully immersed in water. We have to note this point. We can find decrease in reading until and unless stone does not fully immersed into water. Once stone fully immersed into water, there will be no decrement in reading of spring balance and no decrement in length of string also. So we have this point here. What do you infer from the decrease in the extension of string or reading of the spring balance? What can we infer here? We know that if we want to stretch rubber band, we have to apply force like this, that is in opposite direction. And if we want to shrink this rubber band, we have to remove this, or we have to apply force in this direction like this. If we want to stretch it, we have to do it like this, opposite direction. And if we want to shrink it, we have to do it like this. In this experiment, this string will shrink. So what will happen? There should be some force that is in upward direction. Here we have string. This will elongate more in starting of experiment, and it will elongate less after reading, or say after experiment. What is experiment? We immerse stone in water. So there should, or there must some force acting upward on stone and string. This force is transmitted by stone on string. What is transmission of force? For example, if I have this 4 object and I applied force in like this, what will happen? I applied force in this object only, but this 3 also feels this force. Why? Because as I applied this force, it will transmit in both this all object. That is the transmission of force by object to another object. So here we know that the elongation of produced in the string or the spring balance is due to weight of stone. This elongation is due to weight of stone. Since the extension decreases once the stone is lowered in water. As a result, it means that there is some force on stone in upward direction.